All right, so what we're gonna do is we're gonna graph other parent function. You learned all this in algebra 2, but I'm gonna reinforce it. It's that next test gonna have all different kind of graphs, or pretty much all the basic graphs. So let's just review all the parent function. We know how to graph. If you have copy paper, it would be nice. All right. All right, so this is y equal to x. Everybody should know that. Y equal to x squared. Everybody should know that as well. X squared should look like this. Did we talk about y equal to square root x graph look like? Okay, so y equal to square root x. Let me review this. This is for the y equal to x. This is odd functions. Functions. And this is an even function. And this has a domain of negative infinity to infinity. Range is negative infinity to infinity. You should know that this one's negative infinity to infinity for domain. Range is from 0 to infinity. Okay. Question so far. This one is a square root x. What does square root x graph look like? Anybody recall? Yes. You learned in algebra 2.
Go on the left side of that.
No one knows in this classroom what is a square root x graph look like.
Yeah, doesn't it like? Oh, it's like.
Yeah, doesn't it just do this?
Almost, but it's not.
Oh.
Okay, yeah, that's it. If I would do x, y, if I plug in 0, I'm gonna get 0, but I cannot plug in negative number. So I can plug in 0, it's gonna give me 0. If I plug in 1, it's gonna give me 1. If I plug in 2, then it'd be square root 2, and you have no idea what a square root 2 is, but you should know what a square root 2 is. It's about 1.414. And 3 is square root 3, that's equal to 1.7. And the square root 4 is gonna be 2. So basically, you only need a major point, which is the one not with decimals. So it's gonna look like something like this, and this, and this. So it's like a sideways parabola, but it's only halfway. Now I have the reason why I have a name for this name is, do you see football? Like a football is like, football is like this, right? Like this, right? That's a football, right? So I called it as a quarter of football. And the reason why I call it quarter of football is because later, I cannot talk over you, because if you want to talk, then you come up here and talk. I don't have the energy to talk over you. So the reason why I call it quarter of football, because later next year when you're in calculus, that we're gonna rotate this graph across x-axis. It's gonna really look like a football. But right now we're not there yet. Right now we are only in pre-calculus, so we just told you that we're gonna name this graph as called 1/4 of football. So a quarter of football. Now, this point is an anchor point, and this can be transformations. Of course, that transformation graph is going to look like somewhere y equal to x plus x minus h plus k. Then it's going to be like this. So that just says, for example, y equal to square root of x plus 4 minus 2. This graph, this point is gonna translate which direction. Raise your hand if you know which direction. How many unit and which direction, how many units?
Isn't it left four?
Who says left 4 down 2? Good. So everybody says left 4 down 2? Yeah, exactly. 1, 2, 3, 4. And down 2 is going to be like this. Now, it's going to go according to the same points. Do you see this point is go 1, 1 and 4, 2. So it's going to be here. This look like a quarter football, and this graph is continuous, obviously. So it's going to start right there and go there. And obviously I can put negative sign. If I put a negative sign here, then it will be going this way instead. So if I have a negative sign in the front. Is that okay? Just like before, it's no different than before. Yes, Roger
No, right on.
and Arthur. Slope doesn't affect anything because usually I'll give you 1 in the front because it's really hard to adjust. But if it's today is 2, right? Today, let's just say this is a 2, then this point is going to be twice as much, and this point is going to be twice as much. So it's going to go like this. If it's a 2, that means every single point is going to be double. Yeah, just make it elongated. It's called vertical stretch. Is that okay? Now, how about this? You're gonna grab this one and you're gonna tell me domain and range about this graph, okay? So that's at y equal to x minus 3 plus 2 and negative, and I want you to graph it and tell me domain and range. Domain and range. Not only you graph it, you can tell me domain and range. Did you graph it? Did you tell me domain and range? Actually, domain of this is 0 to infinity and 0 to infinity for domain of the range of original function. Okay, is this okay or no? So this one is gonna go which way? It's gonna go right or left or up and down?
Right and up.
Right and up. So this one is gonna be right here. But usually you will go to the top like this. Usually it will be like this. But this is a negative sign. So it's gonna invert that downward like this and like this, right? And then this graph should go in this way and touch this point right here. And you can draw an arrow. Let's keep on going. Of course, you can keep on going. But domain is gonna be for where? What's the domain? Domain, you're gonna take a pencil, and somebody says, how do I do it? Take a domain, it's gonna go in from, take a pencil, and start scanning. As soon as you start at first, which is start at 3, so be 3 to infinity. Is that okay? And range is gonna be here. This is gonna keep on going down, so range is gonna be from negative infinity all the way to 2. Is that okay? Because you take, yeah. So domain is gonna be from 3 to infinity, and negative infinity to 2 bracket. So this is a good question to ask the domain and range, because this one has a pretty unique one.
Wait, so it's negative infinity for both. It's like for both of them because it's like going down, right?
No.
Domain is both, isn't it?
Domain is to go and take a pencil and go in this way. And until you hit first point, that's the first number you write down, and all the way to the end. So the first point I write down is going to be right here. If I draw a line like going here, the first point I intersect is start at 3 and go to infinite.
Why?
Y is going this way, but this lines keep on going down, so it will intersect this and all the way to here. So it will stop at 2. You're gonna pass that because that's a graph too. Okay, so yes, go ahead, Tree.
The first point I get, but once I find the second part, is it like
Oh, the first one is gonna be, it's like going down 1 1, and it's gonna be 2 4. It seems like this. See, this is 1 1 4 2. So it's gonna go 4 units to the right and going 2 units down, just like a square root part.
we have learned this?
You have learned this?
No, we have learned minus 1 over 1. We have learned
Minus 1 over 1. What is minus 1 over 1?
The A?
Oh, the A is negative?
yes.
Oh, so that A has nothing to do with slope. In this particular case, A has nothing to do with slope. Maybe for the first part, but not the second part. It's not this is not a slope. This negative H is gonna be reflect like a mirror, reflect the football graph to the other half. So it's gonna reflect. So this is the point you need to know. So this is the point you need to know. This. If it's negative, it's gonna go this way. Does that make sense? If it's a negative, it's gonna go this way. Are we okay here?
What happens if you go one more?
Huh?
What happens if you go one?
What do you mean one more?
Is it 4-8?
Huh?
Is it 4-8? If you go.
Oh,
Like have one
if
more
you
point.
if you go one more, yeah, it's 9 3. 9 3. So it's gonna be all the way here,
Oh.
and it's 3. It's because square root of 9 is 3. It's like a parabola, but it's sideways, just like what he said, but it's half. Okay, any questions so far? Now, once I graph this, once I know this, I'm going to introduce a new parent graph. Well, we also know this one, right? Y equal to absolute value x. What does that look like? That looks like a V, right?
It still looks like it's
And the vertex is at 0 0. Now, I'm going to ask a tricky question, guys. This question is kind of interesting, but I want you guys to think about what a graph will this one look like, okay? What if I combine this graph and this graph together? Okay? Combine this graph and this graph together? Devin, I need you to pay attention. Okay, so what if I combine this graph together? So what if I have y equal to square root x graph? Look, without graphing calculator, can you tell me what this graph look like?
Here.
Hmm?
Why was that?
Yeah.
Something that's square.
It's not x either.
Is that stretch S?
It's what?
Stretch S?
It's stretch x now.
S.
Huh? S, no. Ella, wake up. Man, between you and Devin, both of you guys either I didn't pay attention or I need to put people awake. You wanna go wash your face and come back, that's fine.
Not just normal, like-
No, I want you to think about it.
Value.
What?
Is the absolute value?
How do you know?
Because you can't square root a negative number.
Oh, Julian. Julian's on track of everything. Good job, Julian.
Yo, he's got the degree.
So think about this, right? Y equal to x squared, and this one's y equal to square root x. And what if I combine both into one? You got y equal to square root of x squared. Okay, good job, Julian. That's very nice thinking. A lot of you guys thinking yes, but he was thinking about you cannot square root of negative number. So because something you will square and it will actually. So the truth is the definition of absolute value is actually square root x squared. Okay, so now that just so you know that there is a very unique situation. A lot of people don't know this stuff. Like even some teacher doesn't know this stuff. So we just want to tell you that this is actually very interesting. Now we want to go to other pairing function. I want to go over one of the most particular one. Actually, how much time I have?
You have 20 minutes.
Okay, good. I can go over some normal one. X cube. We already did this one. What does x cube look like? It looks like waterfall, right? It looks like something like it's like something like this, and the 2 is gonna be 8. So it's look like this, and so this is the waterfall. Now this point is where it transform. That point is gonna take the waterfall transform everywhere, just like what you did before, just like what you did with the x squared. Now I'm also gonna teach you other ones. So let's say y equal to cube root of x. Now what does cube root of x graph look like? Good try though. Yes, Robert.
I'm just thinking.
Okay, other people have
Is it the is it like the right side? Someone say a sideways waterfall? Is it the same as the normal square root, but it also goes negative?
It's like a strategy stop for it just
all right. So somebody, Julian says somebody mentioned sideways waterfall. It's not like waterfall. It's like a downstream. Like it's like what I'm saying.
I think Julian's.
So it's gonna be this way. And the reason why you have a negative sign unlike the square root is because you can cube root of a negative number. Because technically, can I plug in the x and y chart here? Can I plug in -8? Yeah, -8 is going to be cube root of -8 is -2. So it's going to be right here. -1 is going to be -1. It's going to be right here. 0 is going to be right here. 1 is right here. 8 is 2. It's going to be right here. So that is a cube and cube roots. And that's one of the basic graph. Okay, the last one. It's on the last test. I told you don't have to worry about it.
We do.
But now you do, yes. It's a 1 over x graph. Okay, so anybody know what a 1 over x graph look like?
Why? Are they, is it a line?
It's not a line. Good guess.
But it's like along the y-axis, not like along the x-axis.
What'd you say? Like, oh, I see,
You got
yeah,
Like curve up
a
here.
vertical.
Like curve up here and then curve down there.
All right, so we're gonna plug in some value to test this, okay? So x and y, we're gonna plug a bunch value here, and we're gonna show you what happened. So what happened if you plug in 2?
1/2.
1/2, right? Actually, what happened if you plug in 4? 1/4, right? What if I plug in 2?
1/2.
1/2, good.
Yeah, it just keeps getting smaller.
Okay, so what happened if you plug in 1? What happened if you plug in 1/2?
That's fraction.
So what happened if you plug in 1 over 4? What happened if you plug in 1 over 10? Do you guys see the what I'm going to?
Yeah.
Now this is only from the positive side. We're gonna go from the negative side too. Okay, we're gonna go from the negative side. So negative side is gonna go backwards. We're gonna plug in backwards. So it's like, this is gonna be -4. What's -4?
1 over negative.
Yeah, 1 over -4. What happened if you plug in -2?
Negative.
-1/2. What happened if you plug in -1?
Negative.
-1. What happened if you plug in -2? Oh, sorry, not -2. -1/2.
Negative.
-2. What happened if you plug in -1 over 4? -4. What happened if you plug in 1 over 10? 10. -10, right? So we're gonna sketch this graph. Now let me ask you a question. What happens if you plug in 0? No. Undefined. Good. So now we're gonna go to 1, 2. This is by units, so I can count. Okay, so that's the plug-in 4. 4 is gonna be 1 over 4 like this. 2 is gonna be 1/2. And the 1 is gonna be 1. And 1/2 is gonna give you 2. And 1/4 is gonna be give you like this. So the graph is gonna be something like this. It's not an exponential function.
I did that once.
Okay, so that's understandable or no?
Yeah.
Now I'm gonna go plug in -4.
Oh.
That's gonna be this way. And if I plug in -2, it's going to be -1/2, so it's going to be here. If I plug in -1, it's going to be this way. And this is going to be this way, and this is going to be 4 units, so it's going to be this way. So its graph is going to be like this. It's known as a reciprocal function. If you ever reciprocal functions, and also known as a rational function. If it's a first parent function of rational function, so you can think about it's also rational because you have fractions and it's not a straight line. Now, why is this function? How do I represent, like, so for example, like linear function, you can represent something linear. Let's just say, that says somebody work at, I don't know, Panera Bread, your brother.
Oh my God, Virginia, it's the same fancy.
Yeah. So let's say he get paid what, $14 an hour?
No,
15?
wait. No, yeah, 14.
14. Okay.
Yeah.
So that means he get paid $14 an hour each day or each hour. So and then 2 hours gonna be $28. 3 hours gonna be $42, and so on and so on. That would be a linear representation, right? That's a straight line can be represent. If I have y equal to 14x, then I can represent that. Isla, wake up. My goodness. Okay, so that's going to be a straight line. But which kind of situation that you require 1/x graph to represent? Like which kind of scenario from that happening? Okay, yes.
When divide the money for each person.
Good. Okay, so that's a good thing. No, that's today. Say that's you go on the field trips, and this field trip we're gonna rent a bus, and the bus costs $200, right? So in this case, a $200 bus rental fee. Rent a bus, right? And we say, okay, well today only Elizabeth going on the field trips. Then she had to pay $200. So that means if I have one person, then I will have to pay $200. Now, if Elizabeth and Darshini says, Darshini is like, I feel bad for you. I'm gonna go with you together. So then the two people, then it's gonna be $100. Each person's gonna share $100. Now, usually, if it's a linear relationship, then 3 person, you should probably end up to be 0, right? Because you got usually linear, right? If it's a straight line, they have the same difference. However, if 3 people, then it's different. 3 people, everybody's gonna pay like $66. So that's very hard to calculate. So let's just say the whole group, Elizabeth, Darshini, Brandon, and Gia says, okay, well, we have 4 people now. Then now it's gonna pay how much? 50. So this is a good representation because I can have 5 people. Arthur says, I want to join you guys. And they said, no, we don't want you, Arthur. So then 5, that's going to be 40 people. But they want to save money. You say, okay, Arthur, come on. You might have to chip a little bit more money because we have to accept you, right? So let's say if it's 10 people, what will happen? Each person paying what? $20. And guess what? What if it's 100 people? $2.
Yeah, that's right. Good math.
What can we? I mean, realistically, we probably cannot fit 100 people in a bus unless you're in India.
Damn it!
I'm so racist. No, actually, that's true. I'm
That's
not
not
even racist.
racist. That's just
And
rude.
that's true. In India, do you see like people hanging outside a bus? Cuba does too, actually. I don't know if you ever. I went to Cuba.
Some parts of Brazil, like a lot of South America.
It's just based on a lot of people. Like São Paulo has 42 million people.
I went to Cuba once, and there was people literally like hanging outside a bus, and it was like, just like hanging. It's crazy. All right, so
Wait, did
but
Indians like you?
Huh?
Did Indians like you?
India. What do you mean?
You went to India?
No, I didn't.
Oh.
I went to Cuba.
Do they like you?
Yeah, they like me. They give me a ride. I hitchhike at Cuba.
I'm so
I got
shocked
right.
you could do that.
No, I got a
I
ride.
figured you would have got murdered.
And they were like, come on, come on, come on. Where you going? And I get on a ride. On Cuba. They were really nice. Yeah.
Now they make you get shot.
No, Cuba is actually really safe. They have a cops everywhere. It's actually very, very safe.
You would have used it. You would have used it.
It's really safe, honestly.
You can make it.
All right, so shh.
Makeup.
Shh. Let's just say this is a magic school bus. You can fit a lot of people in there, right? It doesn't matter how much people you fit there. It does not go to zero cost. You can fit 1,000 people in the bus, and everybody's gonna pay like 5 cents or like whatever. I think it's 5 cents. 2 cents. Okay, I can calculate. So let's say if you fit 1,000 people, everybody only pay a little bit, but they're not paying zero. So that's the idea of asymptote is like this. Asymptote is never get to zero. It doesn't matter. I can fit 1,000,000 people in there. Everybody gonna pay a fraction of a cent. So, but it's still a little bit, but so close to zero. That's why the idea of asymptote. The asymptote is this. This asymptote is right here. Sorry, that's asymptote. This is called a horizontal, a vertical asymptote, and there's a horizontal asymptote. And this is a very interesting vocabulary because this is probably the second time you see this. It's called vertical asymptote. And this is called horizontal asymptote. Okay, so it's like this is you get really close to there, but you'll never get there. It's kind of like Arthur's future relationship.
God damn, I need
I'm sorry. You know, your only purpose that you are in this class so I can make fun of.
Is that why you haven't kicked me out yet? Is that the only reason?
Your only purpose. I'm just kidding. I love you, Arthur.
Oh, I know you do. That's on camera, by the way.
Oh, okay.
Yeah.
Shit. Are you gonna have a clip?
I'm gonna go home. I'm gonna get into my voicemail and be like, "I love you, Arthur."
All right.
You think I'm joking?
All right. So it's gonna go close, so close. You know, at least Arthur is not gonna report me to like I don't know. At least
Yo,
I don't
people
think.
who are poor people in school, a bunch of
No
wizards, bro.
way.
Holy shit! I mean, I only tackled one person. If you reported, that's fucking.
You talk with a girl.
Okay, and in the Big 25,
You tackle a girl?
it was
How?
okay. I would tackle a guy.
You were like 200 pounds. How are you gonna tackle a
You're
girl?
like 20. Yeah, I took his ass down. Old man.
Okay, so shh. A lot of people say I have problem memorizing this graph. So I used to make fun of this graph, and I think a lot of people in the back in the day they throw like gang signs. As I was make fun of like Mr. Ye's gang sign look like this, and basically this is how you memorize the graph. So it's a 1 L on top of the L, and it's gonna be a first quadrant and a third quadrant. Okay, so it's gonna be like this. Shh. Also, understand that there is a point where they intersect the asymptote. This point is kind of special. This is how they how they transform. How did they go up and down, left, right? So this is the point. No, there's no such a term. I call this as the anchor point. This is where the anchor is. So today, if I say, hey, graph me y equal to -1 over x plus 4 minus 2. Now you see that there is a parenthesis here. You see there's a parenthesis right here, right? So that means the anchor point is going how many units to the which direction? To the right or to the left? It's actually to the left. 1, 2, 3, 4. And this one is going where? Down 2. So down 2. And this is where the anchor point. Guess what? Use the anchor point to draw 2 asymptotes. And asymptotes here. And so draw 2 asymptotes like that. Now I'm gonna graph, but the problem is this one's negative. It's like a reflection. So usually without that negative, let's assume that the negative sign is not there, the graph's gonna go this way. But the problem is there's a graph negative sign there, so that it's gonna go this way. Because it's gonna reflect according to that point, because you got a negative sign over there, so it's gonna go from like this, your gang sign is gonna flip to the other way.
Don't say that.
That's okay. Cancel me.
No, don't say cancel.
I think it happens, like, people probably try to do that, like, multiple times.
Cancel me.
What's the worst like report that you got?
Have you gone before?
You
Yeah.
definitely got him reported. Come on, man.
Oh, really?
I got a lawsuit.
Did he make your
You got wait.
Yeah.
Here's my question. Here or was it somewhere else?
I hate
Did you win?
My
If he lost, he wouldn't be here. You go back to China.
boyfriend thinks you're racist.
Who's your
I
boyfriend?
don't think you're racist, Jim.
Kaya?
It's because he thought that he told him to get out as soon as he got in here. He thought it was because of his skin color. But it's just, you don't have him. It's that.
He's not racist because racism means that you don't like specifically one race. He doesn't
I
like
hate
any
all
of them.
race equally.
In fact,
Actually, I hate Korean the most.
hey, I think we might be able to. I hate Korean most. Looks at Ella.
Actually, Korean. Actually, I like it's probably the best Korean. One second, third best Korean.
Jinju.
Jinju.
He said best, second, third.
Jinju. Who's the second best? Oh, Cookie.
Cookie is so great, bro. Oh my god, he's so funny.
And then
Chase. He's descendant.
Chase. Chase is pretty good. Chase is pretty good.
Top dog.
Chase is pretty good.
Chase top dog. Elliot.
No, it's the problem. Is I have like all the lazy Koreans.
You literally falling asleep like white people.
Oh, anyway, I'm gonna get canceled. Oh well. All right.
Yeah, add it to the counter.
Yeah.
Yay, cancel counter.
All right. So this is how you transfer this graph, and you can have a restriction now. You can say so when to stop. Like say if you want to stop from here to start here, then you just cut a graph off here, cut a graph off here, or whatever. Depends on what your domain restriction is. But you still follow the same transformation as before. There's no difference. Does that make sense for everybody? So remember, if the positive, if this is negative, it's going to be second quadrant and the fourth quadrant. It's a positive. Write down. If it's a positive, then it's going to be first and fourth, first and third. And if it's negative, it's going to be second and fourth. So you know which quadrant to be.
Can you name the quadrant?
Oh yeah, quadrant. Okay, so quadrants like this. This is a 1, 2, 3, 4. Wait, 4 is this way, right?
No.
It's IB or BI.
Yeah, it's IB. Come on.
Okay, it's C. It's going C. So it's 1, 2, 3, 4. No, it's C. It's going C because C could be anywhere though. Like he has to be from counterclock. Counterclock. Let's go against the clock.
And you're live.